Hello everyone and welcome. In this series, we'll be looking at Geospatial Python. And in this first video, we will introduce ourselves to how we can represent vector geometries with Python. So how to represent points, lines, and polygons. We will also continue to look at how we can create and read shapefiles. We will introduce ourselves to that. And then we will conclude with an introduction to projections also. This series assumes that you have a Python geospatial development environment set up already. If you don't have it, there is a link in the description that will lead you to a video on how to set it up. And I think the link should also pop up somewhere now at the top right of the screen or the video. And also, it assumes that you have QGIS installed. If you don't have it, the same video will show you how to do it. And inside the QGIS, I want to make sure that you have a particular plugin installed called Quick WKT. We'll be using it today and in subsequent videos. And so you have to come to manage and install plugins. And you search for Quick WKT. Once it pops up, you will see install plugin, but because I have it already, it's asking me to either reinstall or uninstall, and I'll not do any of those. So I'll close this one and make sure you have those two set up, and then we can begin. Alright, so the editor of choice will also be Visual Studio Code. Now how we can represent geometries. Shapely is the Python package for geometry manipulation. So that is what we'll be using. And to be able to get to use it, we have to import it. So this one we are importing the geometry types from Shapely. So we have to say from Shapely.geometry, we want to import, and then we can import point, line string, they call it a line string, and then polygon. So the lines are called line strings. Just take note of that. Also, I want to import OS. I like to keep the Python default libraries on top. I also want to import Fiona because we'll be using it. That is for the shapefile manipulation, the creation and the reading of the shapefile. So I want to import Fiona also, and we will do some transformation. So let's import the PyProj also. Or maybe let me keep it in cells so that when we get to Fiona, we import Fiona rather. So I'll run this one quickly and I don't have an error. So how do we represent a line? A quick markdown. So this place will be points first, a point. Well, a point is as simple as you call the point object like this and then pass in x, y, and an optional z. So if it has a coordinate of 1 in the x, 1 in the y, I can add an optional z of maybe 2 or z, whatever the value is. And I have a point. If I print out the type of this point variable, I'm going to get a Shapely class of points. Right. But if I print out the point itself, then I am going to get this that we call the WKT, the well-known text. WKT, And this is what we can plot using our WKT plugin. If you also just want to see the points in the notebook, the Jupyter notebook, I'm sorry I forgot to mention that I already have this Jupyter notebook created. Of course, we have started typing code in it. So I have my folder here with a notebook created, so please do same. Sorry. But the link to this notebook will also be in the description for your reference. If I print point, I'll get a WKT, but if I just call points in this notebook, I should see a plot of it here. So that is our point. But this is not how we really want to visualize it. We will take it to QGIS for better visualization, at least until we get to how we can create visualizations using Python. And so I'll go back and print the point. What I can do is to copy this and then come to QGIS. Your window may not really look like this. I've increased the sizes so that you can see without zooming in or straining your eye. But if you finish installing the WKT plugin on your plugins toolbar here, you should see an icon that looks like this with the W, K, and T, with the K being red. When you click on it, this window will open. If you're having difficulty finding that icon, come to plugins and you should see Quick WKT. When you put your cursor on it, you can click on Quick WKT. The same window will pop up again. Now, if I paste what I copied from my VS Code and I give a layer title of say points, and I press return, enter, or I click on OK, I should see this point object created here for me. If let me come to symbology, I can double click on it to achieve that. I increase the marker size to maybe 5. You see that that is my point over here. And I put my cursor on it to check the coordinates at the bottom. I'm at 1, 1. So that is how we represent points in Python. And we can also do some point operations on this one. So if I have another point, say point 2, which is also a point object of say 2, 2, this one has no height. I can equally print that point 2 also. So let me duplicate this one and print point 2. I'll get this point of 2, 2, copy it, come to QGIS, to my WKT, and then paste that one in here. Oh, I already know that it's 2, 2, so I can delete this one. Since my copy did not work, and I can make this one point 2, press return, and then I should be seeing that point also somewhere. Let me right click and zoom to layers. Okay, did I paste the wrong coordinate? Or this one size is overshadowing it. Let me decrease the size to 2 and see. Because I'm expecting to see 2 points here. Let me delete this one and paste it again. Okay, so it's expecting a Z, which I did not give, so let me just give a Z of 1. I think that was the problem. Zoom to layers, and I check this one off. Where is points? Let me also zoom to layer and see. Okay, it seems it's there, but they are far apart. Okay, now the two of them are here. So this is it, the 2 points. And we can perform some operations, basic operations on them. If I want the distance between the 2 points, I can now say maybe distance from point 1 to point 2. I can say distance is equal to point dot distance, and I pass in the other points. So I pass in 0.2. When I do that and print out the distance, or even in a notebook, I can just call it. So I can just say distance, and that comes in, and that is correct because this is from 1, 1 to 2, 2. So this is the value we should get. We can come to QGIS and confirm that. My distance measure 2 is here. So I just click here, drag it up to this point, and okay, we don't really have, I think I should change it to Cartesian and see. Because of how these things are calculated, it will be wrong, because on the ground, this one is calculating the distance for us as it is on ground, but we are using the mathematical way of determining the distance between 0.1 and 0.2, but this is the distance between 1 degree and 2 degrees. So it should be different, but because we have now applied coordinate systems to this one, this is the value that should give us, and mathematically this is correct. Okay, so we can get a distance also, and that is it. We will come back to these ones and explore them into details, most of the things that we can do with them. But for now, let's move on to lines. So to represent a line also, I can just say line, and that will be a line string, and I pass in a set of coordinates. You know, a line needs at least 2 coordinates to define it, so you can't put a single coordinate in the line and for it to work. If, for instance, if I pass in, let's say 1, 1, and I run, I will get an error that should tell me that that is a wrong shape for a line string. So for a line string, I need more than 1 coordinate, at least 2. But those 2 should be inside a list. And so I can now say another point in the line, which is 2, 2, or 2, 3, doesn't matter. When I run it now, I don't have an error. I call line. I will see the line also drawn over there. And if I want to get the well-known text, I can now print this line. And I get this. So I can copy this, come to QGIS, and then I paste it in. This is not what I wanted to copy. Copy cell output. And then this one, I'll name it line. Once I press OK, if I come back to QGIS, I should see the line here drawn. So maybe it doesn't really show on your screen. If I increase the width to maybe 5 and the color to something bright, like red, that should show us the line here. Okay, so that is also how we represent lines in Python. So it's also a line string. For the line also, there are a couple of things that we can do with lines. So we'll just explore a few and we'll go into detail as we progress. So if I print line.length, it will give me the length of the line. If I print, if I call the dot notation on it, I can see almost all the things that I can do with this line. Not all of them work on all geometries. For example, if I had to check whether this line has an area, which we know it doesn't, I can now say line.area, and automatically it should return 0 for me. That is because these geometries have, the methods are kind of shared for all of them. The Shapely does it so if even with a point I can decide to compute for the area, and instead of it to maybe give me an error, it will give me 0 for that. So the line, we can compute only the length. So let's just do the length for now. If we have other lines also, we can also check for intersection and all those ones. But as I said, let's reserve those ones for subsequent ones. And let's see how we can also represent polygons. For polygons, is also close to the line, just that that one should be 3 or more. So I can just say that polygon, that should be equal to polygon. And if I just copy these two here and paste it, if I try to run it, I should also get an error again, that a linear ring must have at least 3 coordinate tuples. I choose to call it a linear ring also because Shapely sees it as a 2-dimensional figure which is bounded by a linear ring. So for instance, if I have like 4 points, the perimeter that encloses all those 4 points, that is what it is calling a ring. That is why if the error was saying linear ring instead of polygon. It is looking at the perimeter that encloses all those points that make up the polygon. So what it is saying here is that we should add one more coordinate tuple, and so that could be any number, a random number like 5, 3. I don't want 3 again, maybe 5, 7. And this one, it will not complain. So if we call polygon, I don't really like the shape of this polygon. Let me add one more, which should be 4 and then 8. I still really don't like the shape of this polygon. Let me come to, so let me just search for WKT. And this first one that is from Wikipedia, let's just select that one. And inside the Wikipedia, if you want something about the WKT, you can read it here, but I just want to get some of these shapes from Wikipedia. And so that will mean that I can copy one of these. So this is a polygon. Let me copy this, come back to the code, and then paste the tuples in. But I have to put commas here and then wrap each of these pairs also as a tuple. So I wrap it and then I place the comma there. Okay. Now if I run this, I have an error. Okay, linear ring must have at least 3 coordinate tuples. This one and this one should go. And now I have this shape. So if I want to also get a WKT, like we copied from Wikipedia, I have to print this one out, and then I can copy the cell output and then come into QGIS, open my WKT and paste this in. Maybe I'll call it polygon. And then if I zoom to area, the layer, sorry, as you see my polygon here defined. So that is also how we represent polygons in Python. If I want to also, for polygons, I can check something like the area. And this is the area. The perimeter is actually the length also. So if you want to get a perimeter, that is the length. So the length of the ring around it. Okay, so that is also how we represent polygons. So now let us move on to performing some spatial operations. So let us create a new point, which also will be a point object with coordinates of, say, 4,4. And then let's create a buffer around this. So creating a buffer, we can say buffer that should be equal to new point dot buffer, and this one we pass in the distance. So we can say maybe give us a buffer of 5. Now this number here, the distance, is in the units of the CRS. So if we say buffer, we will see the buffer around the point, but we cannot put this point on the buffer here. So what we can do is to come to QGIS, so we can print the buffer, and this will give us the WKT for the buffer. If you triple click inside it like this, you can have it all selected, and then you copy the cell output. Now the point is 4,4, so I will come in here, and what I want to do is to select everything and remove it, and create a new point that will represent our point in there, which is 4 space 4. So that will be our point. And then we create another one for this polygon, the buffer that we have. So I'll just paste that one in, and then that is the buffer. So if I bring the point on top of the buffer, you should see that I have the point and then its buffer. If I bring up the symbolic, the size a bit, let me say to 5, and the color to something bright like red, you will see that the point is in there and this buffer is around it. So that is how we create buffers in Python. And let's also, if we have a line, we can also draw the buffer around the line in the same manner. For instance, let me put a new geometries all here. So new line, that should be equal to line string, and this one will have some coordinates of let's say 1,1, and the last point is 3,3. Okay, so if I print this new line, not the line, new line, I have a line string here which I can copy and then draw in QGIS. So let me draw this one here. Okay, I have to copy it again, copy cell output. It is not really allowing me to do that, but this is it. I can delete this part and I have my line. This is our line. And so if I come back to QGIS, it should be somewhere. It falls inside the buffer, so it's difficult to see, but if I turn it off and I increase the width a bit, then the color to say red, you see that our line is visible. Okay. Now we can create a buffer around this line also. All we have to do is to now say line buffer that should be equal to new line dot buffer, and then we can set this buffer to maybe 3. If I print the line buffer, I will have this polygon also. I can copy, come to QGIS, and then paste it in. So I can call this one the line buffer. And I have a buffer around my line. If I bring the line on top, you should see that the line is there and the buffer is there. One cool thing about this buffer with lines is that you can specify that this distance is 3. This place is also a distance, but I didn't specify it explicitly because I'm not adding other things. But here I can say single-sided is true. And when I print it out and copy this, come to QGIS, delete this line buffer and create a new one, or maybe I should keep it there and then add a new one rather. But let me make it invisible and then add a new one. So line buffer 2, something like that. And you see that now the buffer is on just one side. It is on this side if the value is positive like this. But if the value here is negative, it will put it on the opposite side. So if you wanted it at this side, the right side, if we are going from where my cursor is now, from the lower part to the upper part, then if I put a negative figure like -3 this time around, it will put the buffer to the right side. But with a positive figure, it will put it here. So let us run it and inspect that one also. So I copy cell output, and then I'll come to my WKT. Line buffer, this should be 3. If I press OK, you see that now it puts it at the right side. So if you want it at the opposite side, I can't really say left or right because that depends on whether you are coming from the top to the bottom or from the bottom to the top. But if you want it at the other side, you know whether to put negative or leave the value as a positive integer. So that is it also with buffer with lines. We can also check the distance between points, which we have already done. We can check whether a particular point is within a particular polygon, or whether a particular polygon contains a particular point. And we have them here. So we can check whether a point of, say, 6, 6 is within this buffer because the point itself is 4, 4, and we did a buffer distance of 5. So I'm anticipating that the point with coordinate 6, 6 should be within this buffer. So I can say new point 2. Forgive me my variable names. One of the difficult things to come up with is variable names. So new point 2 is 6, 6. And so if I want to check whether, let me call it query. So I can say query is equal to buffer dot contains new point 2. If I print out query like this, it is true because that point is definitely inside it. Let me check 16, 16, and that turns out to be false because it is far away from the buffer. And I can also check if it is within the buffer of the line. It will work the same way. In another sense, I can also flip this query and now say, so if let me comment this one out. If I now want to check whether the point is within the buffer, I can now say query is equal to new point2 dot within, and then I can say buffer. That one is false. If I bring it to 6, 6, 1, that should be within it. I think so. Yes, and so that is within it. So the query at line 9 can be also written in the form like it is at line 10 also, depending on how you want to put it. Also, we can check for intersections. So this one is how do I even give a comment here? So contains or within. We can also check for something like an intersection. So let's see intersection. In that case, you can check whether the line intersects the polygon, or whether the polygon is intersected by the line, or that is the line passes through the polygon. So we can also say that intersection, and that should be equal to, let's take the line buffer. For that we know that it should, but let's take the buffer dot intersection, and then we can pass in the new line and see. So new line, and then we print out intersection. Okay, sorry, this is we are creating an intersection, another geometry, but I can say intersects, and that one will do it for us. So we can also rewrite it like we did for this one also, but if you want to check whether something intersects something, you can do it this way. Also, we saw that we can create an intersection of two geometries. So let's come to QGIS and see what will give us a more practical example. So if I bring up this buffer, okay, so we can create an intersection of the buffer and maybe the two buffers. Yes. So let's do that. So buffer.intersect, and then let's say line buffer. So if I get the intersection like this, we already see, but let's still print it out and see. Maybe it is smaller at your end. So if I print this one, I'll get the WKT. We can copy this and then come to QGIS. Then paste it in. So this is a intersection. And immediately you see that's the green one. So if I turn off that should be buffer 3. And toggle between buffer and the intersection. You see that it only gives us the intersection of the two geometries as a new geometry. So that is the work of the intersection. We can also do union. So let's try that one too. We can do, maybe we will not try the union here, but you can do union if you want to do that. That should be union. But for that one, let's bring up everything. The line buffer completely engulfs the two, so that will not really work. Let me see the buffer. And it looks like okay, we can make a union of the line itself and then its buffer. Let's see. So union equal to line buffer, I think that's how we call it, line buffer dot union of the new line itself. And then we can print the union. We're having two prints here. You don't need this one. And we copy the cell output, we bring it to QGIS, WKT, and we call this one to be union. Let me check all of them off and see. Yes, it's a union, but we cannot really see, maybe for this type of geometries. And so you can twist the geometries to very irregular ones and then try it, and you will see that the union also works. But it looks like our geometries are just so perfect that if the union is carried out, you don't really even see the difference that's made. So those are also some of the spatial operations we can perform on geometries. We cannot go into all of them that Shapely has to offer. So if you, for instance, have a geometry like this, so you can say new line, you press dots, any intelligent editor like Visual Studio Code should give you all of these things that can be performed on the geometry. So you can check whether there's a difference, there's joints, or you can even interpolate here and all that. So if you have a line too, you can simplify it, and you can see whether it touches, maybe a line touches a particular circular geometry or anything like that. So you can explore these ones also. But for now, let us move on to how we can read and create shapefiles using Fiona. So shapefile input, output with Fiona. So we have to import Fiona, and this is where the OS we imported will be of use. We want to create a directory called SHP that will contain all the shapefiles that we will create. We don't have a shapefile yet, so we'll create one and then we'll read it. We cannot read what is not there. So the directory which I want to create a shapefile is os.path.join. I want to join the current directory with a path that is called SHP. It doesn't exist yet. If I expand you see that it doesn't exist, but if we want to create it, we can say os.make this, and we pass in this directory. And if we don't pass exist okay equal to true, the next time we run the cell, if the folder exists, it will throw an error. But if this flag is here and the folder exists, it will not throw an error. And so what I can do is to run this one, and then when I come, you see that my SHP folder is created. Great. So that is a directory. So you can also define the shapefile path. Or I can even call it SHP path. It's okay. That one to be os.path.join. We want to join the directory with a file called let's call it file.shp. So this one is also not created yet, but we will use it in code. I like to structure my things in simpler pieces where possible. So how do we create a shapefile using Fiona? We first define what is called a schema. So this is first, let me say, creating a shapefile. We first define the schema, which can be any variable name. Schema. Okay. If you are familiar with database language or databases, you know that a schema is like, if I should say it less technically, it's like the structure of the table, but not the table itself. It defines how the table will look like. And in this case also, it's the same thing for the Fiona. So it defines how the shapefiles attribute table will look like, but it's not the attribute table itself. So let's see what it can contain. A very important field is the geometry field. Now, this name is not a random name. It should be exact. You should type geometry for it works. And here you define it whether it should be a point, line, or polygon. So I'll choose point for now. And then the next one is called the properties. This one is also not a random name. It should be exact. And inside the properties is also where you put in now the attributes that you want your shapefile to have. So all the, let me say, the columns of your attribute table, that is where you put it. So I may put a name column here, and this place too, I just tell Fiona that it will be a string. Remember, this is the structure, not the table itself. So if I want other things like maybe a description, which I'll shorten because shapefile attribute column length should be less than 10. If it is more, it will chop it off. So I can say this place is also a string. If you have other things to add, you can say maybe other. And whether it is an integer or a string or even a float, you can put it there. So I'll leave it this way. And this is it. So we have the schema now. What do we do next? We now create the shapefile. And we can go with fiona.open. If you are familiar with Python, you know that you use the with open to open a file, and you first pass in the file name. So ours is the shapefile path. And if the file does not exist, if you're now creating it, you pass in the W flag, which is the right flag. But for Fiona specific and shapefiles, we have to pass in some other things also. So we have to pass in the schema here. We can set it to go to our schema that you have at the top. And then there should be the driver also, which is Esri shapefile. Let me put these ones on separate lines. I can leave the W on that line. And also I can specify the CRS to be equal to, let's take EPSG 4326, which is the WGS 1984 Geographic and I can open it as maybe file. Okay. So when I open it like this, then I can now write to the shapefile. So I can say point equal to, and then now I define the point to match this schema. What am I saying? So if I bring up the dictionary here and I say I have to find the geometry, and in here the geometry type, I also have to define the type here, and that should be a string also. The type as a point again, and then I pass in the coordinates. These are not random names, it should be exact. So the coordinate for this particular point, let's just say is 1, 1. And then now I can come and pass in the properties also, just like I defined in the schema. So I can say properties, and that one also maps to, now I have a name and a description to give. So I can say that the name is maybe point 1, and the description is some description. So now this my point matches the schema at the top, and once I have it like this, all I have to do is to say file.write, and I can write points. If you call it as maybe DST, you say dst.writePoint. Let me open this shapefile, the folder to you. See that there's nothing in there. I refresh, there's still nothing in there. So I'll keep it open and I run this one. You see immediately that the shapefile has been created with all its accompanying files. I can come to QGIS, select all of these. And remove them. I have added this folder here as a favorite, so you can do that. If you don't have it, just right click, add a directory, and choose the directory where you are doing your Geospatial Python stuff. So if I open this one and the SHP folder, I see the file.shp we just created. When I drop it, it looks so small. Let me increase the to 5, and then OK. Okay, something is wrong with my QGIS. For some reason, I'm not able to really fit it to the entire screen, but no problem. If I open the attribute table here, you see that I have the name and a description for some description. Those are the things we created in code using the schema. So now that we know how to create the shapefile, how do we read a shapefile? So how do we read the contents of this shapefile that we have created? It's quite easy. That will be with Fiona.open, and it's the same shapefile path, but this one we can pass the optional read. Let me read it as DST, and then it reads the things, let me just say, let's technically the rules inside it as features, because it's a feature class, so it contains features. So we can access it like for feature in DST, print feature. When I run it, I should see it here. Now, depending on your version of Python and the version of the Shapely Fiona library you are using, you may not really see this. You may have to nest into the dictionary and get things yourself. But you can see for my own that it shows. I have the description, the name, and other things also. I called it feature here, but you can actually say for I in, and it will work. Python doesn't care, but I love to give proper names to my variables also, because it's a feature class and what is in there are features. So that is also how we read a shapefile. It's just that simple. But if, for instance, this particular what if you wanted to create something like a multi-point shapefile? Now this one is a single point. So for that one, what we will do is, let me bring up some points here from my notes. So the same schema, but I'll have a point here called file points, just so that I don't type all of these while you are watching. So it's just a point files that follow this particular schema. So I just have them in here like this: 0.1, 0.2, 0.3, 0.4. You can see that this place I shortened it. It will not really matter, but let me use coordinates so that this place will all be consistent. Okay, so that will be consistent with the code. But the COORD will also work. So now I have this one here. How do I now create the multi-point shapefile? Well, like regular Python, we can do almost whatever we want in this width block. So we can go and say for maybe item in file points. Then we create a point for each of them. So we can say point equal to, and then that will be, for each of them, the type is point, but for the coordinates here, we will get it like item, and we just access the coordinates. And for the name too, that will be item name, and then item description. So let me just copy this. Item name, and the description is item is it info DSC, like that. Okay, so I just loop over them and then I write them. But for this one too, it should be inside the for loop block for it to work. Now if I comment this place for a while, or I can even leave it because the first one will run before the second one. So if I run this, I have a key error. It says coordinate. I forgot an A somewhere. Here. Now I have the 4 points showing here. If I come back to QGIS, remove this one for now, and I bring it back, I see the points here. If I increase the symbology just a bit to maybe 4 and a bright color, you see my points also here. That is also how we represent, we create and we read shapefiles also using Fiona. But as we move along, you see that it's actually really a bit difficult. Not difficult, but it's just too much code to create a simple shapefile. In real world cases, shapefiles will be complex. Multi-polygon, imagine a multi-polygon, an irregular shape that you have to create using this method. That would be so tiring. And so as we move along, we find out how we can create these ones with more simpler methods and other simpler packages or packages that makes these processes simpler. But it is necessary that you understand from the grassroots how these things work. And so if you have to do any customization for any special or specific case, you can do that with ease. But for now, what we will do is to go ahead and look at how we can perform some simple transformation in Python. So that will be an introduction or performing transformations. Performing transformations. For that one, we need a PyProj library to do that. So from PyProj, we import transformer, and then we import the CRS, not the lowercase, the uppercase CRS. If we want to transform from one coordinate to the other, we first have to define a transformer, and then we use the transformer to transform the coordinates. So our transformer, that should be equal to transformer dot from CRS, and in here we pass in the from CRS and the to CRS. So I'll choose EPSG, the 4326, which is the WGS84 Geographic, and then the to CRS, I'll choose EPSG 32630, that is the BGS 1984 UTM Zone 30 North. And if you want to know more about all of those things, you come to epsg.io, and then here you can search for the coordinate system for a specific country, or if you know the code like I do, you can just put in 32630, press enter, and then it should give you the details about a particular coordinate system. So I just know it, that's why I typed it in there. So let me come back to epsg.io. Okay. So when we have the transformer like this, we can use it to perform our transformation. But there's a very important variable, this always xy. If true, the transform method will accept as input and return as output coordinates using the traditional GIS order. That is longitude, latitude for geographic CRS, and eastern, northern for most projected CRS. So if you don't set always XY to true, then it means that you have to pass in latitude first, followed by longitude, or northern first, and then followed by the eastern. So we'll just look at that one shortly. For some people, they are used to eastern, northern, and then longitude, latitude. Others too are used to latitude, longitude. So depending on your preference, you can set it here. And so if I want to get a particular coordinate, I can say XY, or in my case that I've not really set the XY to true, that would be YX rather. That should be transformer.transform, and I pass in my Y and my X, or my that should be latitude first or longitude. Let me see, that will be latitude first. So I have Google Earth also, Google Map also open here. So maps.google.com should take you there. Let me zoom in inside somewhere in Kumasi, and then I'm looking for the Kwame Nkrumah University. So this place has this roundabout. That is why I'm particularly interested in. If I click, I can copy these coordinates. Remember, it is in the form of latitude and longitude. So the first one is the latitude, and the second one is the first one is the latitude, the second one is the longitude. So if I come back and I paste it in here like this, because I'm not using the always XY, this format is correct. But if it was always XY, then the longitude, which is the negative value, should have come first. So let me print the transformation. So I can print that should still be YX. I have this. So these are my UTM coordinates. Let me copy it. Let's inspect it at epsg.io to see whether we are correct. If I come to epsg.io and I go to get position on a map, here I will change the coordinate system to 32630. I will select this one and then I will paste it in X at one place and then the Y2 at one place, and then I'll zoom in but not to that place. So you see that now somewhere even in Burkina Faso, or maybe somewhere in Ghana, but even not close to the place itself. But if I bring my cursor here and press enter or return, it should take me there. I don't think I copied the right coordinates. It doesn't start with 8. Let me print them separately. So print X and then print Y. Sometimes copying stuff from the VS Code is difficult for me. I don't know why it doesn't copy. When I press enter, it has zoomed into a place. Let's see. And that is not a place. If you remember clearly, I have to swap these positions. And it still didn't work. Why is it so? Okay, so let me just pass my always XY here. So I take it in the format I'm most comfortable in. Always XY to true. So that I know that I'm getting X, Y here. So let me run it now. And in that case, I have to switch the position of these ones too. And when I save myself from the X, Y issues, I now have it. It's not really pointing to the middle here, maybe because of how I selected it here. I did not. But you can see that that is the place. That is the roundabout here. So we have been able to also make a successful transformation from the WGS to the UTM zone 30. So you can save yourself if you are comfortable with the other way around, like northings first before eastings, or the longitude first before the latitude. You can ignore the always XY. But if you think you find it difficult, like I just did, you can just put in the always XY equal to true. That is this side. You can put it in equal to true so that you don't have yourself to blame for any errors like that. Okay. Also, if you have a particular coordinate reference system, you can check the details. So let's see how that one will go. Let's just say that a CRS equal to CRS dot from underscore EPSG and then 4326. If we print this one out, you see that it gives us some details here about a particular coordinate reference system. And so if you want it this way, you can do that. This one is just an introduction to transformations, and we will delve deeper into coordinate reference systems in subsequent episodes of the series, where we can even create our own coordinate reference system. But for now, this is the end of this particular episode. If you like the video, be sure to give it a thumbs up, and if this is your first time, consider subscribing and sharing the video to your friends who might also need it. Thank you very much for staying around up till now, and until next time, it is goodbye.